So I don't think it is appropriate for anybody to say or anyone to say I don't like mathematics. In as much as I know that in our everyday life we do mathematics, while cooking, while driving, in business, and even to wear your clothes. I don't know if you know that to wear your clothes it requires some level of calculation. So when my students complain I don't like mathematics, I just ask them a simple, do you who wore your clothes today? Who wore your clothes? Who dressed you up? So I don't think it is appropriate to say you don't like mathematics. You do calculation on daily basis. So if there is anyone there that is able to give you the simplification of the algorithms, maybe to make it in a present it to you in a very simplified format, I think the calculations should be embraced.
Hello everyone, you are welcome in today's class. And today we are going to be looking at still linear and quadratic graph. And what we are going to be doing today is that I am going to show you how to do this problem right inside your graph. We are going to see how you can do it right inside this place. Okay. That's what we are going to be doing. I know in the last discussion, maybe some of you may be wondering, still having some little issues on how to put it inside this place and then do the sub questions that follow. Answer it, take a proper reading of the values here. So that is what we are going to be handling in our today's discussion. The question says, copy and complete the table of values for the relation y equals to 3x squared plus x minus 7. And the linear one, this is the quadratic, this is the linear y. The linear one says y equals to 4x plus 5. This is the interval given to us. Minus 3 less than or equals to x less than or equals to 3. Okay. So using a scale of 2 cm for 1 unit on x-axis, okay, and 2 cm for 10 units on y-axis, they plot the graph of these relations, and then using your graph, this graph we are going to do, they determine the solution of this problem, 3x squared plus x minus 7 equals to 0. Okay, now this is another question there. Is it at what value of x is this equation minimum? So using your graph, determine the solution of the equation 3x squared minus 3x minus 12 equals to 0. So we are going to do the table first. Okay, do the table and then we do the graph as well. Okay. So as I was saying, the first thing you do, I have made a copy of this, question, 3x squared, plus x minus 7 for the quadratic and 4x uh, plus 5 for the linear. And this is our interval that is given to us. So the first thing you do here is you make the table of values for the relation. And we are going to quickly do that. So we have it as a table of values for y equals to 3x squared plus x minus 7. So that's that. And then we put the range of values for x, which is x ranges from minus 3, minus 2, minus 1, 0, 1, 2, and 3. Okay. All right. So we have this. Mhm. Then we put these terms inside this place. Here will be 3x squared. Here will be x. Here will be minus 7. And finally, y. Okay, so now here, this is 3x squared, meaning all the values of x here will be squared, then multiplied by 3. That's the meaning. So here we go. You do something like this, create a space like this. You have 3 in bracket, then squared, so that when you bring minus 3, put here, minus 3 squared will give us 9. 3 times 9 will give us 27. I will write 27 here. Okay. Minus 2 squared will give us 4. 3 times 4 will give us 12. Minus 1 squared. Minus 1 squared is 1. 3 times 1 will give us 3. So you keep on putting them. 0 squared, 0 times 3, 0. 1 squared, 1 times 3, 3. Okay. 2 squared, 4 times 3, 12. 3 squared, 9 times 3, 27. So that's how you feed this, that space, that line. Okay. Then this is x. You see, it doesn't have any coefficient with it. It doesn't have any coefficient. So if it has 2 here, something like 2, you realize that we are going to be like use that 2 to multiply all these values of x. But there's nothing like that. So for that sake, it is just like a repetition of all that you are seeing here. So we have minus 3, minus 2, minus 1, 0, 1, 2, 3. So all these values that are here, bring them down as they are. Okay. Minus 7 is a constant, so I'll write it across. Minus 7, minus 7, minus 7, minus 7, minus 7, minus 7, minus 7. Then the y values is just addition of all these things, except this interval. Don't add them. So let me use line to separate them. Okay. So 27 minus 3 minus 10, 7 is minus 10. 27 minus 10, that will give us 17. Okay. 17. And then 12 minus 2 is 10. 10 minus 7, that will give us 3. 3. What do we have here? This is this is 3. 3 minus 1 is 2. Then 2 minus 7, that will give us minus 5. Yeah, minus 5. We bring down minus 7. Then 3 plus 1, that's 4. 4 minus 7. I think that would, yeah, 4 minus 7 is minus 3. Minus 3. Okay. So 12 plus 2 is 14. 14 minus 7. 14 minus 7 is 7. 7. 27 plus 3, 30. 30 minus 7, that will give us 23. Okay. So this is the table of values for the, you can check these things out. Please take a look at them, use your calculator, verify these figures, and see that they are in order. All right. So the next is table of values for the linear part. So I will say table of values for y equals to, so we have 4x plus 5. Okay. So now, because this is a linear equation, the linear problem, I mustn't take all these points, all of them. So I can take minus 3, that is x. I'll take x minus 3, then take minus 1, take 1, take 3. Okay. So so the first thing that will exist here is 4x. I'll put 4x here, and then followed by 5, which is a constant. Then y. So 4 is multiplying all the x values. Okay, so 4 times minus 3 will give us minus 12. 4 times minus 1 will give us minus 4. 4 times 1, 4. And 4 times 3, 12. This is 5, 5, 5, 5 because it's a constant. Then we bring them together to get all the y values. Minus 12 plus 5, that will give us minus 7. That will give us minus 7. Then minus 4 plus 5, that will give us 1. This is 4 plus 5, 9. This is 12 plus 5, that's 17. I think I'm done with this table now. The next thing is to go and prepare this graph so that all this information can be represented inside here. And the first thing I do here now is to write the table. I say graph of y equals to 3x squared plus x minus 7 and y equals to 4x plus 5. So, and then I think keep this by one side and have my pencil. Then I will try to see, because if you come here, you realize that the maximum value here is 23 and the minimum is minus 7. So I will check how I can be able to present this graph in a way that that maximum value will be accommodated, even though they gave us a scale to use. The scale says 2 cm for 1 unit on x-axis, 2 cm for 10 units on y-axis. So when I come here, I will begin to look for a place I can make the origin. If I choose here, I will verify that 10, 20, 30, that the maximum value, which is 23, is accommodated inside this space. And from here down, the minus 10, which is the minimum value, is also accommodated. So I think here, making here the origin uh, is good. It's okay. Then I will also check this way, 2 cm. These blocks have 10 tiny blocks inside. That's why it is 2 cm. Okay. So here, every 2 cm, 1 unit on x-axis. Here will be 1. Here will be 2. Here will be 3. And from here, minus 1, minus 2, minus 3. So my verification is complete. So I can now move on to put those things in position. So here is 1. This is the origin. Here 1, 2, 3. This is x-axis. Then this side, minus 1, minus 2, minus 3. Okay. Here 10, 20, 30. Okay. 30. This is my y-axis. And then down here, minus 10, minus 20. That is the negative part of the y-axis. So here we go. When x is minus 3, y is 17. So I will come here to look for 17. So this is minus 3. And if you look here, from here to here, here is 10, 11. Let me show you something. You realize that from here to here is assigned 10 units, and there are 10 tiny blocks inside here, meaning that these 10 units divided into 10 will give you every tiny block to be 1 unit. So reading 17, I think is easy. So here being 10, 11, 12, 13, 14, 15, 16, 17. So you scratch something there to locate it. When x is minus 2, y is 3. Okay, so we come over here and have minus 2 against 3. This is 1, 2, 3. The 3, this thing there. Can you see that? When x is minus 1, y is minus 5. So this one now we have to go down, step down. So this is minus 1 being on x-axis, and minus 5 will be minus 1, minus 2, minus 3, minus 4, minus 5. So I'll mark something there. Okay, when x is 0, 0, y is minus 7. So I will also come here and also count minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. I'll mark something there. When x is 0, I think I've taken that now. When x is 1, y is minus 3. So when x is 1 is here, y being minus 3, minus 1, minus 2, minus 3. I will mark something there. When x is 2, y is 7. That's now on the positive side. So x being 2, y being 7. 1, 2, 3, 4, 5, 6, 7. Mark something there. When x is 3, y is 23. So I will come from 3, this is 10, this is 20, 21, 22, 23. I'll mark something there. Okay, look at it. Okay, so I think I'm through with that. We can now join these points with the flexible stuff, something that is flexible. Okay, either a flexible ruler or anything that can be flexible to produce a curve. Use it. Okay, okay. So I think this is the curve. The next thing we do, we write y equals to 3x squared plus x minus 7. The next thing is the linear part. The linear part says when x is minus 3, y is minus 7. So we come here, x being minus 3, y being minus 7, we take it down. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. We mark something there. When x is minus 1, y is 1. When x is minus 1, this is minus 1. You know we jumped to minus 2. So minus 1 and 1, just a step up. When x is 1, y is 9. X is 1, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mark something there. Okay. When x is 3, y is 17. So 3 and 17. This is 3. This is 3. This is 10. 11, 12, 13, 14, 15, 16, 17. Mark something there. So I think I'm through with that. To use my ruler to join the points. I told you that you mustn't do all the points because the others will fall in line. The others will fall in line. So this is a right graph of y equals to 4x plus 5. Okay. So I think we are through with this now. The next thing to do is we start taking the sub questions. The sub questions, the first one says, using your graph, determine the solution of 3x squared plus x minus 7. What is the meaning of this? This simply says, what is the solution to this quadratic problem? And in using a graphical method in solving quadratic equations, okay, where the solution lies is where x passes through the x-axis. Where this curve passes through the x-axis. You can see it here. Look at it here. You have to read what here is saying. Now, if from here to here is 1, it then means each of these tiny blocks that are 10 in number will be 0.1. You can check it out by saying 1 divided by 10. That's 0.1. So it then means as here is minus 1, minus 1.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.6. Okay. Though it went after it, maybe not exactly at 0.6, after it, 0.6 and half. So 0.1 divided by 2 will give us 0.05. So 1.6 plus 0.05 will give us 1.65 minus 1.65. So I can quickly say that's question CII. No, CI. Determine the solution of this. So I will say CI, the solution. You are seeing what I'm writing there. The solution of 3x squared, okay, plus x minus 7 equals to 0 lies at x equals to minus 1.65 and y equals to, and x equals to, because it lies the value of x at this point and the value of x at this second point where it got the s-axis. Okay, you can see the two locations here, the value of x here. Okay, and then we have taken a reading of that one. Let's take a look at this one. This is the origin. So we are checking out for the value of x here. So here is, from here to here is 1, 1.1, 0.2, 0.3 and half. So that should be 1.35. Okay, because this block here is 0.1. If you check into it 2, it will be 0.05. So 0.05 plus 1.1, 0.2, 0.3 plus 0.05, that would be 1.35. That would be 1.35. That's what I'm saying is, yeah, 1.3 plus 0.05. Yeah, that would be 1.35. So it is at x, you write that it is at x equals to minus 1.65 and x equals to 1.35. Okay, so this is the second value of x. So let's look at the next question there. The next question there says, at what value of x is this problem minimum? This is the quadratic equation we represented in this curve. So at what point is it minimum? It's very simple. It is at this bottom, the minimum, the least position, the least point of this curve. That's where it is minimum. Alternatively, you can find it from this table. You can see the minimum value and you see the corresponding value of x. You get it. So where you now say II, the value of x for 3x squared plus x minus 7 being minimum is at x equals to 0, y being minus 7. So that's the solution to that. Okay, so anywhere this curve, because whether the curve goes like this and goes like this, just always take out the minimum, the bottom of it, the minimum point. Okay, all right. So finally, we are given another question that says what do I have? Say, using your graph, determine the solution to the equation 3x squared minus 3x minus 12 equals 0. So this, sorry, I made something here. So see clearly the question. Using your graph, determine the solution to the equation 3x squared minus 3x minus 12 equals to 0. So, I will show you something. Permit me to ask you this logical step question. If 10 is equals to 5 plus 5 and 10 is equals to 4 plus 6, is it wrong to say that 5 plus 5 is equals to 4 plus 6? Is it wrong? I don't think it is wrong. Now, you are giving here that y is equals to 3x squared plus x equals minus 7 equals to, no, minus 7, just minus 7. And that same y is equals to 4x plus 5. This is y equals to 3x squared plus x minus 7. Okay, minus 7. Leave this. Then y equals to again 4x plus 5. Is it wrong to say that since this and this y is common, is it wrong to say that 3x squared plus x minus 7 is equal to 4x plus 5? I don't think it is wrong. It is still the same, logical statement we had here that is being made here. It is not wrong. So let me collect like terms here and check out something. If I write 3x squared plus x, bring down plus x, bring over, it will become minus 4x, bring down minus 7, then bring over minus 5 equals to 0. There's nothing on the left hand side there now. So we have 3x squared, x minus 4x will give us minus 3x, and minus 7 minus this 5 will give us minus 12 equals to 0. Does this look like this? Check out both of them. 3x squared, they say determine the solution from the graph of 3x squared minus 3x minus 12 equals to 0. 3x squared minus 3x minus 12 equals to 0. What does they have any connection? Yes. So that is to say that they are asking you at what point is this quadratic problem equal to the linear problem, and sometimes they will put it like this and say using graphical method solve this pair of simultaneous equation. Solving this pair of simultaneous equation, one is quadratic, one is linear, is simply asking you that when you have done this graph, find their point of intersection, because that point of intersection, let me check it out. Look at it here. That point of intersection is where the two problems are equal. Their values are equal. Look at it also here. Can you see their point of intersection? So I'm going to mark it out so that we can be able to determine their values in the x and y axis. So here we go. Stop at the x axis and also check it out on y axis. The value of y. Check the corresponding value of y. Okay. So then let me also mark this place before I can start taking the reading. There is a point of intersection here. Very close to almost like 1. Okay. Now remember that this thing I'm teaching you here is not static. That it is depending on where your own will lie, so that you don't be narrow-minded in reasoning what has happened here. Okay. So you realize that how I'm going to answer this question. Let's read what is going on here. This is 10. No, one block here is 1 because here we've explained that before. This is 10, 11, 12, 13, 14, 15 and half, meaning 15.5. And here is 2, 2.1. You know this place is 0.1 each. 2.1, 0.2, 0.3, 0.4, 0.5, 0.5 and small 10, maybe 0.52. So I will say for my question C, is it C, I, O, D? Question D. For my question D, Okay, I will say the solution to 3x squared minus 3x minus 12 equals 0 lies at x this side 2.12345 x equals to 2.52 and y equals to, I'll check out the corresponding value of y from here. I have ready to be 5 point, this is 10, 11, 12, 13, 14, 15, 15.5. Y equals to 15.5. Okay. Then I will also come this side, read what is here. You see this point of intersection is at, from here to here is minus 1, 0.1, 0.2, 0.3, 0.4, 0.5. So it's minus 1.5 minus, and x equals to minus 1.5 and y equals to, y, check what y is saying from there to y axis. Okay, here is 0 point, I mean minus 1 and something, little portion of this. So I can call it minus 1.3 minus y being minus 1.3. So this is how to, use graphical method to answer or solve a problem of this nature. Okay, a problem of this nature. So I'm thinking, I believe God that this explanation is very, very okay and can help you from the table of values of the quadratic, table of values for the linear, uh, the graph, okay, then the title for the graph, then the scale should be here given to you, or you put it in a space somewhere here, depending on the nature of the graph you use. Then you can, the explanation for this example is not exhaustive. So I'm going to also make another problem, the solution to another problem, so that we can be able to tackle the necessary questions that one can possibly face. I'm I'm trusting God that when you know what you're supposed to know, there may not be any need for one to be having issues or involving oneself in the examination malpractice or engaging in things that can, implicate you. So I will trust God to give you whatever I can be able to make available to help in this, project that we have. All I expect from you is like this, video, and subscribe, share it to your friends and families, and as many out there that you are desiring, the best for. Thank you so much. I remain Victor Odigoma or here, your mathematics tutor in this program. Thank you so much.
So I don't think it is appropriate for anybody to say or anyone to say I don't like mathematics. In as much as I know that in our everyday life we do mathematics. While cooking, while driving, in business, and even to wear your clothes. I don't know if you know that to wear your clothes it requires some level of calculation. So when my students complain I don't like mathematics, I just ask them a simple, who wore your clothes today? Who wore your clothes? Who dressed you up? So I don't think it is appropriate to say you don't like mathematics. You do calculation on daily basis. So if there is anyone there that is able to give you the simplification of the algorithms, maybe to make it present it to you in a very simplified format, I think the calculations should be embraced.